Hi, this is Ms. Sek. This is a pre-recorded video for solving equations using distributive property. Students will be able to solve linear equations that require expanding expressions using the distributive property. Let's review some vocabulary. A variable is a letter that represents an unknown number. This equation has two constants. A constant is a number that has no variable, and a coefficient is a number that multiplies a variable. Let's review distributive property using a real-world example. So let's talk about a combo meal. This combo meal is 2 tacos and a drink. So what this is saying, this 3 is outside the parentheses. This is saying there are 3 sets of 2 tacos and a drink. So if there are 3 sets of 2 tacos and a drink, there's 6 tacos and 3 drinks. Let's review. The commutative property says that you can add or multiply numbers in any order and get the same answer. And the associative property says that we can group numbers that we add or multiply and we get the same answer.
Let's do some problems with the distributive property. And the distributive property just essentially reminds us that if we have, let's say, A times B plus C, and if we need to multiply A times this, we have to multiply A times both of these numbers. So this is going to be equal to A times B plus A times C. It will not be just A times B, then plus C. And that makes complete sense. Let me give you an example. If I said 5 times 3 plus 7. Now, if you were to work this out using order of operations, you'd say this is 5 times 10. So you'd say this is 5 times 10, which is equal to 50. And we know that that's the right answer. Now, use the distributive property. That tells us that this is going to be equal to 5 times 3, which is 15, plus 5 times 7, which is 35. And 15 plus 35 is definitely 50. If you only multiplied the 5 times the 3, you'd have 15 and then plus a 7. You'd get the wrong answer. If you're multiplying 5 times these things, you have to multiply 5 times both of these things because you're multiplying the sum of these guys. Anyway, let's just apply that to a sampling of these problems. Let's do A. So we have 1/2 times x minus y minus 4. Well, we multiply 1/2 times both of these. So it's going to be 1/2 x minus 1/2 y minus 4. And we're done. Let's do C. We have 6 plus x minus 5 plus 7. Well, here there's actually no distributive property to even do. We can actually just remove the parentheses. 6 plus this thing, that's the same thing as 6 plus x plus negative 5 plus 7. Or you could view this as 6 plus, so this right here is 2, right? Negative 5 plus 7 is 2. 2 plus 6 is 8. So it becomes 8 plus x. All right, not too bad. All right, that was C. Let's do E. E, we have 4 times m plus 7 minus 6 times 4 minus m. 4, let's do the distributive property. 4 times m is 4m plus 4 times 7 is 28. And then we could do it 2 ways. We could have, let's do it this way first. So we could have minus 6 times 4 is 24. 6 times negative m is minus 6m.
So I want you to notice what he has here. What he has here is a negative, and then he has parentheses, so he has to do distributive property. So he's going to put a -1 to represent that negative so that he's able to use distributive property.
And notice, I could have just said times negative 6 and have a plus here, but I'm doing it in 2 steps. I'm doing the 6 first, and then I'll do the -1. And so this is going to be 4m plus 28, and then you distribute the negative sign. You could view this as a -1 times all of this. So -1 times 24 is minus 24. -1 times minus 6m is plus 6m. Now you add the m terms. 4m plus 6m is 10m. at the constant terms, 28 minus 24, that is equal to plus 4.
So let's look at a real world problem. Here we have 3 donuts and 4 bagels. So if there are 3 donuts and each cost 95 cents, and there are 3 bagels and each cost $1.15, we could just add 95 cents and $1.15, get $2.10, and multiply by 3 to get $6.30. But another way is to use distributive property. We multiply 3 times 95, which we get is $2.85, and 3 times $1.15, $3.45, and we add those two together using distributive property, and then get $6.30. This is what it looks like algebraically. 3 times each thing inside the parentheses.
Alright, for this problem, what we're going to do is we need to solve for our variable. But before we solve for our variable, remember we need to simplify, right? And the way we need to simplify is we need to get rid of these parentheses. So what we do is we use our distributive property. We multiply whatever's outside our parentheses to everything that's inside of the parentheses. So therefore we have negative 243 equals a negative 90 plus 9x.
Now he just made a mistake.
Craziness. But it's all for good, so then he does.
So he made a mistake here. Negative 9 times x is negative 9x.
Okay. Then we add 90 both sides. Yes. Yes, it would be a constant minus 9x. Minus 9x. Okay? Then we're going to say this becomes negative 243 plus 90 is a negative 153 equals a negative 9x. Right? Now we need to determine, now we need to undo what's happening to our variable, which is multiplied by negative 9, so we need to divide by negative 9. Right. This is a lot of extra stuff, isn't it? Okay, right? So, if we don't have a calculator on us, there's a couple ways we can do this. One way, you can do the old method. You do long division. 9 goes in 15 one time. 1 times 89 is going to give you, actually, let's just do about 16. 9 is going to give you 9. Down there is 63. 9 goes into 63. 6 7 times. Another way you can look at it is, I don't want to do yes, let's just with this. So you can just go and solve it, use long division. There is a couple ways in your head, but I'm not going to worry about. So therefore, a negative divided by negative gives you a positive. So x equals 17.
Okay, so when you're looking at an equation, scan both sides of the equation to see if there are expressions that can be simplified using the distributive property. So let's practice. So negative 3 times the quantity of x plus 2. So we're going to multiply negative 3 to x and negative 3 to 2. Negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. Now we have a two-step equation. We're going to get rid of the constant. We don't get rid of the negative 3 first. That's the coefficient. We get rid of the constant that's near the x. So we're going to add 6 to both sides. And then we divide negative 3 on both sides to get positive 2. I would like you to solve this problem. I'll give you 30 seconds to solve it on your paper. Okay, so we multiply 6 times x, which is 6x, and 6 times negative 3, which is negative 18. And then we have to get rid of the constant. Now notice I did not get rid of the 24. Why? We're trying to get rid of the constant that's by the x. Negative 18 is by the x. So we add 18 to both sides, and then we divide by 6. The answer is 7. Let's try one.
Grade 8 Math, number 7.3c. More linear equations and more distributive property. This time we're going to do a real-life problem. So we said in the previous video that distributive property can be useful for solving equations. We distribute a factor to all the terms within parentheses, then solve for the variable. So remember, we need to apply the distributive property before we isolate the variable to solve it. Before we isolate that variable on one side, because the order of operations says to simplify expressions inside the parentheses first. So here's our real life problem. It's going to be a restaurant problem. Emma's family had their restaurant bill reduced by $7.50 because of a special discount. Maybe they had a coupon or something. They left a tip of $8.90, which was 20% of the reduced amount. So how much was their bill before the special discount? All right, so they had a restaurant bill. They had a coupon or something that $7.50 was taken off, and they left a tip of $8.90, which was 20% of the reduced amount. We need to find out how much the bill was. So the answer is the amount before the $7.50 discount. If we can find that amount, we'll have the answer. So we're going to make a plan. We're going to write an equation to find that amount before the discount. All right, so here's our equation. This is the 20%, the 0.2, because 20% is 0.20. It's 1/5 of a dollar. It's 20 cents of a dollar. So 0.2 is going to represent the 20%. The x is that amount before the discount that we're trying to find. The 7.5 is the $7.50 discount. We don't need to write that 0. 7.5 is good enough. 8.9 is the $8.90 tip that they left. That's the 20% tip. We don't need the 0 after that either, really. Okay? So now we got our equation. 0.2, x minus 7.5 in parentheses equals 8.9. Now we can just simplify it and solve it. So the first thing we do is we're going to use the distributive property to solve it. Now, before we discussed multiplying by powers of 10 to get rid of decimals. And we could do that, and I'll show you at the end of the video, but it won't affect this guy. Because he's inside parentheses, he's still going to be 7.5, because that would be multiplied by 10, and that would be multiplied by 10, and he'd stay the same. So we're just going to do this as decimals. So 0.2 times x is 0.2x right here. 0.2 times negative 7.5 is negative 1.5. 7.5 times 0.2, see, is 150. And because there was 1 hop, 2 hops in the equation, there's 1, 2 hop.
So once we've used distributive property, she multiplied 0.2 times x and 0.2 times negative 7.5 to get this answer. Now she's treating it like a two-step equation. So she added the constants and then finally divided by the coefficients. Okay, now, if you're in the live class, the students that take the live class, they just finished their vocabulary assignment right now, and then they're going to do quizzes after class. But since you guys did not do the live class, you have to do the line paper assignment, which is in Google Classroom. Okay, I'll see you next week. Bye.